Okay, here's number 1, where we've got this function g of x. By the way, I think this hat should have been out here. It's g of x, the quantity squared, I think. We're assuming that g of x is some function of x, so when we take the derivative of g, we have to multiply by the derivative of the inside, chain rule. So when we take the derivative of this first term, we're using the power rule. Reduce the exponent by 1, and then multiply by the derivative of the inside, which we'll call g prime. The derivative of 12x with respect to x is just 12. Over on the right side, we have to use the product rule. So we'll take the first function times the derivative of the second, which is g prime, plus the second, g of x, times the derivative of the first, 2x. Now at this point right here, let me erase this one because it could be interpreted as a prime. At this point right here, we could substitute 12 in for g of x because we want to find g prime of 4, or we could actually go to the trouble of isolating g prime so that we have a general formula, and that's what I done in these steps down here. Get the terms with containing g prime on the left side of the equal sign, the other terms on the right side of the equal sign, factor out the g prime, leaving this coefficient of g prime, and then divide the right side by the coefficient of g prime. And there's your general formula. Now we want to find g prime of 4, which means wherever we see an x, we'll put in a 4, and wherever we see a g of 4, we'll put in a 12. I'll let you finish the evaluation. For part 2, we're differentiating implicitly with respect to t. This is typical of related rates problem. We're assuming these variables are all functions of time. So wherever we see a variable, we're going to differentiate with respect to t. So the derivative of y with respect to t is just dy dt. For 2x cubed, we apply the power rule, followed by the chain rule. The derivative of this inside function, x is a function of t, is the derivative of x with respect to t. And for 5x, it's 5 times the derivative of the inside, dx dt. To do the finish up number part 2, we're going to put a 1 in wherever there's an x and a 3 wherever there's a dx dt, and we will find dy dt. And I'll let you do that evaluation too. There you go. Hope that helped. If you have any questions, post a comment.